So now in this problem we are going to show you how to do the supernode analysis. Alright, so what is a supernode? You see, when we learned about mesh analysis, you are basically finding the value of the mesh current, right? And likewise, when you are doing the node analysis, you are basically finding the value of the node voltages, right? So now you have also learned about super mesh. What is a super mesh? A super mesh is when a current source comes in between two meshes. If a current source comes in between two meshes, then those two meshes will form a super mesh. In that case, you are supposed to write the equation of the super mesh. Okay? So just like how you have a super mesh in the mesh analysis, just like that we have a super node in the node analysis. So what is a super node? A super node is nothing but when a voltage source comes in between two nodes. What is a super mesh? Super mesh is when a current source comes in between two meshes. Likewise, a super node is when a voltage source comes in between two nodes, then that is called as a super node. This entire branch starting from this point to this point is called as a super node. And when you say supernode, it is basically that entire branch is considered as a single node. In that case, then that corresponding node will be having an equation. That equation is what you're supposed to write. So let's do this question, okay? This is basically a very simple question. So here, like I said, these two nodes correspond to a supernode. Why? It's a supernode because there is a voltage source in between them. Only a voltage source should come. There should be no resistor or capacitor or any other element between that. Okay, that is, if two nodes are connected only by a voltage source, then that is called as a super node. Just like a super mesh, right? In the super mesh we have two meshes combined by a current source. Just like that here it is two nodes combined by a voltage source. Okay, so now let's do the equation for the super node. Let's do this analysis. Okay, so here what I'm going to do is, just for your convenience, just for you to understand, I will mark this point as V1. Okay, and then this, using this pink color, I will mark the super node. That is, this node is V2 and this node is V3. Okay, so this is V2 and this is V3, which means V2 V3 forms a node. That means this entire branch is a node. Why are we using super node is because I cannot tell you, or I cannot give you the current that is flowing through this branch. Just by applying the standard node analysis, I cannot tell you or write the equation of the current through this branch. We cannot write the equation for the current through this branch, so which means you cannot apply node analysis over here. That is why you are applying super node. That is, by combining these two nodes, you are assuming that this entire branch itself is a single node. Just like in a super mesh, right? Why are we applying super mesh? Because I cannot give you the voltage across the current source. Just like that, I cannot give you the current across this voltage source. That is why I am using the super mesh analysis for this problem. Okay, so anytime, wherever, if you see two nodes combined by a voltage source, immediately you have to apply supernode analysis. So what do you mean by supernode analysis is because just look how we do this problem. Okay, so here I am going to apply the equation for node V1. Alright, as usual, standard, there is no much change, right? Everything is just the same. So equation for node V1. I'm going to write the equation for node V1. So if you look at the equation for node V1, here V1 is connected to three branches, right? 1, 2, 3, which means there are three terms. So what is the current through this branch? It is minus 10. What is the current through this branch? It is V1 plus V1 minus 0 by 3. And what is the current through this branch? It is plus V1 minus V2 by 2, right? And according to Kirchhoff's current law, all this is equal to 0, right? Now I'm going to express this just like normal, like how we did previous problems. I'm going to express this in terms of V1 and V2. So this is V1 into 1 by 3 plus 1 by 2, right? There's no other. V1 is over here and over here, so it's 1 by 3 and 1 by 2, right? Next we are going to write V2, and V2 is only over here, so it is minus V2 into 1 by 2, right? And there's no other, this is equal to, and this is minus 10, so this will become plus 10, right? Let's see what is 1 by 3 plus 1 by 2. Let me see that. It is 3 inverse plus 2 inverse is equal to 5 by 6, which is 0.833. So this is basically V1 into 0.833, okay, minus, and what is this, 1 by 2 is 0.5, right? So this is V2 into 0.5 is equal to 10. This is the equation 1, okay. Now I'm going to write the supernode equations, right? So supernode means, like I said, this entire junction is, this entire branch is a single node, or you are assuming it is a single node. That means the current is in this direction, in this direction, in this direction, and in this direction. See, because this entire, this V2, V3 is a supernode, this entire branch other than this node, not touching this branch, the remaining branches are considered as your current branches. So you need to express the current for this branch, this branch, this branch, this branch. That is your supernode equation. That is equation for supernode V2 V3 or V2 dash V3, whichever is your convenient. I like V2 V3, okay. So in that case, what is the equation? So what is the equation through this branch? It is V2 minus V1 by 2. So V2 minus V1 by 2 plus, what is the equation through this branch? It is V2 by 1. V2 by 1 plus, what is the equation through this branch? It is V3 minus 10 by 5. So V3 minus 10 by 5 plus, what is the current through this branch? It is V3 minus 0 by 2, or V3 by 2 is equal to 0. This is called as the supernode equation. See, that is the current through this, branch plus the current through this branch plus the current through this branch plus the current through this branch. All those branches are equal to, adding all those branches is equal to 0. Now let me write in terms of V1, V2 and V3. So here there's only V1 over here, so this will become minus V1 by 2, right? So I can write this as V1 into minus 1 by 2, okay, plus, and what about V2? V2 is over here, that's 1 by 2. V2 is over here, that's plus 1. And so now there's no other V2 over here, so that's it. Now I'm going to write in terms of V3. And when I look at V3, there is one V3 over here, that's 1 by 5. And there is one V3 over here, that is 1 by 2. So it's plus 1 by 2. That's it, right? No other equation, right? This is equal to, or any constants? Yes, there's a constant, that is minus 10 by 5. Minus 10 by 5 is minus 2, which becomes plus 2. There you have it. So this is basically, let me see, minus V1 into 0.5. And this is 0.5 plus 1, which is 1.5. So this is plus V2 into 1.5. And this is 1 by 5 is 0.2 and 1 by 2 is 0.5. So 0.2 plus 0.5 is 0.7. So this is V3 into 0.7 is equal to 2. This is equation number 2. Now there is one more supernode equation, right? Just like in super mesh there are 2 equations, right? Like that, for supernode there are 2 equations. One equation you have already written. What is the other equation? It's obvious, right? The other equation is regarding with this voltage that is coming in between those. So what is the equation for this voltage? You see, this positive terminal is connected to V2 and this negative terminal is connected to V3, which means the equation is V2 minus V3 is equal to 20. There. This is the other equation. That's it. There you have it. The 3 equations, right? Solve these 3 equations and you can find any value you want. So what is the question is? The question is, find the current through the 5 ohm resistor. What is the, where is the 5 ohm resistor? It's over here, right? So this is the 5 ohm resistor. And what is the current through the 5 ohm resistor? The current through the 5 ohm resistor, first, what is the voltage across this 5 ohm resistor? The voltage is V3 minus 10 because the current is going downwards, right? So V3 is the higher potential and this 10 volt is a lower potential. So therefore V3 minus 10 is the voltage across this 5 ohm resistor. So what is the current through the 5 ohm resistor? It is V3 minus 10 by 5. That's the current through this 5 ohm resistor, right? V3, I think I have written that somewhere, right? Yeah, this equation. V3 minus 10 by 5. This is the current through the 5 ohm resistor. So that value I need to find, which means I need to find the value of V3. If I found the value of V3, then I've already found the answer. So that's the equation. So in that case, you can solve this any way you want. You can apply the matrix method, or you can solve it by a symbol substitution. I will apply symbol substitution over here. So here basically what I want is I can remove one of them. Maybe I will just make this. Here there's only V1 and V2, but here there's V1, V2 and V3, which means I can remove V3, which means I can write the equation for V3. What is the equation for V3? Looking from here, the equation for V3 is equal to, let me see, V3 comes over here, 20 comes over here, so it will become V2 minus 20, right? So V3 is equal to V2 minus 20. This equation I'll substitute over here. So what will I get? I will get, this is substituting equation 3 to equation 2, right? Let me write that. Substituting equation 3 in equation 2. We get minus V1 into 0.5 plus V2 into 1.5, and this is V3. What is V3? V2 minus 20. So this is plus V2 minus 20 into 0.7 is equal to 2. There you have it. So now I can express this in terms of V1 and V2, right? So what you have here is minus 0.5 V1, and here we have 1.5 V2, or this is 1.5, and here you have 0.7 V2. So 1.5 plus 0.7 is 2.2. So you have is plus 2.2 V2, right? And then what do we have here is equal to 2. And what about this? This is minus 20 into 0.7. What is minus 20 to 0.7? Minus 20 means the 0 will cancel. It will become 2 into 7. So minus 2 into 7 is minus 14. If it comes over, it will become plus 14. So it becomes plus 14. This is the equation. So in that case, this is 2 plus 14 is 16, right? So we have minus 0.5 V1 plus 2.2 V2 is equal to 16. This is the one equation there. So this is one equation over here. This is the other equation. Solve these two, then I can find the value of V1 and V2. What I do need is, I'll find the answer. So which means basically, what's the first equation? Let me see. 0.833 V1, 0.833 V1 minus 0.5 V2 minus 0.5 V2 is equal to 10. Is equal to 10. What about the second equation? We have is minus 0.5 V1 minus 0.5 V1 plus 2.2 V2 plus 2.2 V2 is equal to 16. So now what do you think I should do here? Maybe I will, should I use a calculator? I'll use a calculator. That's much more easier, right? See here, if you want, you can use a determinant method, whatever method you like, okay? So here I'm just going to use a calculator just to save time, right? So here, let me see where it is. Calculation is over here, I think. Yeah, this one. A. 1. Number of unknown is 2. So this is 0.833, 0.833, and this is next one is minus 0.5, minus 0.5. The next one is 10. The next one is minus 0.5. The next one is 2.2. And the next one is 16. So we have the first equation is V1 is equal to 18.956 18.956 volt. Let me see if the answer is correct. Yeah, okay. So 18.956, and the equation for V2 is equal to, let me see, V2 is equal to 11.581 11.581 volt. That is a value of V2. Alright, Solving these two, we'll get let me write like that. Solving the equations. Solving the equations, you get V1 is equal to this much and V2 is equal to this much. Okay. So now I'm going to, you can find V3 also, right? What is the equation for V3? V3 is equal to V2 minus 20, right? V3 is equal to V2 minus 20, which is equal to 11.581 minus 20, which is equal to, let me change it back, 11.581 minus 20 is equal to minus 8.419, minus 8.419 volt. That is the equation for V3. Therefore, now I can tell you the current, right? Because V3 is what is required to find the current through the 5 ohm resistor. Therefore, current through the 5 ohm resistor is current through the 5 ohm resistor is equal to, it is V3 minus, let me see, V3 minus 10 by 5. V3 minus 10 by 5, which is equal to, this is minus 8.419 minus 10 by 5, which is equal to minus 8.419, right? So this is basically minus 18.419. Minus 18.419 divided by 5 is equal to minus 3.684. Minus 3.684 amperes. Okay, this is the answer. So this is the current through the 5 ohm resistor, minus 3.684 amperes. What is the meaning of this minus sign? What is the meaning of the minus sign? You are doing this problem under the assumption that the current is flowing from V3 to 10, right? This the current is flowing downwards. But look at the answer you got is minus, which means in reality the current is actually flowing upwards. That's what it means. Okay.